Hello students. Hello students, here is Shittu, your mathematics teacher. This lesson is brought to you by IOTA Virtual Learning. In today's lesson, we are going to be looking at some problems on integration from WAEC and JAMB question. All right, so we have the first one here. We are asked to evaluate the integral of x squared minus 1 ranges from 1 to 3. We have the limit. This is definite integral. We have the lower limit 1 and the upper limit 3, so the x. And we have the options there. So kindly pause the video, solve it, then come and check your result. So now solution. Now from here, I have the integral ranges from 1 to 3, x squared minus 1, or the x. So now if you want to do this, so what we're going to do now is that we are going to integrate each of the terms separately by having 1 to 3, then x squared minus dx, then minus 1 to 3. Then here, you can see this is 1, we have 1 dx. Now, so one thing we're going to do here is that you should remember whenever you are having something like x to the power of n, and you want to integrate this, this is going to be x to the power of n plus 1. You're going to add 1 to this, then divide by the new power, that is n plus 1. Okay, plus c. This is general formula for integration, and you have x to the power of n like this. But here, this is what? This is definite integral. Okay, here the c is constant of integration, but you only have the constant of integration when you have what? When you have indefinite integral like this. But if you have definite integral where the lower and upper limits are given, so you will not have to put the constant of integration. All right, so that's what we're going to do. So now from here, I'm going to have this to be, from here, I will have the integration of this is going to be x2 plus 1. Okay, I'm going to add 1 to the 2, then we have 2 plus 1. Then minus for this. So whenever you have this 1, or we have the x, the integral of this one is going to be what? It's going to be x. Are you getting that? Because we are integrating with respect to x. So now from here, we are going to put the limits 1 and 3. So we are going to put the value of, before that, let's simplify this for that. We have x to the power of 3 over 3 minus x, then put the limits 1 to 3. So what we're going to do here is that you first put the value of 3. This is the upper limit, you put it here. So we're going to have 3 to the power of 3 divided by 3 minus 3, then minus, putting the second, which is lower, 1 to the power of 3 minus 3, okay, minus what? Minus 1. So we have it like this. So this is what we're going to have. Now simplifying this further, so we're going to have, now simplifying this further, we're going to have 3 raised to the power 3, then divide by 3, okay, so that's going to give us 9. We're going to have 9, okay, minus 3, minus will affect this, we have minus 1 over 3, then minus that will be plus what? Plus 1. So from there, we are going to have 9 plus 1, that will be 10. 10 minus 3, that will be 9 plus 1, that is 10. 10 minus 3, we're going to be having 7. We have 7 minus 1 all over 3. By taking the LCM, we're going to be having 3. We're going to be having 3. So how many 1? You can write 7 as over 1 like this. How many 1 is going to see in 3? All right, 3. 3 times this, we have what? We have 21 minus 3 in 3, that is 1. 1 times this, we have 1. So you can see we have 20 all over what? 20 all over 3. In mixed number, you can see that 20 over 3 is going to be, how many 3 you are going to see in 20? That is 6. That is 6 whole number, because 3 times 8 will give us 18. 3 times 6 will give us 18, then remainder 2 over 3. So we have 6 whole number 2 over 3. So which is what we have here, which is the option, what? Options D. All right, so you have the second question. The question says evaluate the integral of cos the x, that is ranges from negative pi over 2 to pi over 2. Okay, so first of all, so this one here, before that, please try to pause the video, do it yourself, then come and check your result. We have minus pi over 2 ranges from minus pi over 2 to pi over 2 cos what? Cos the x. Now, first of all, let's try to change. Whenever you see pi is 180. So when you have pi over 2 now, So that will be 180 over 2, and that will give us 90 degrees. So it means that we can write this as minus 90 degrees, okay, then towards to 90 degrees. Then we have cos dx. All right, so now whenever you want to integrate the cos function, maybe cos m, okay, with respect to this, so this is going to be sine m, okay, so it's going to be sine m plus what, plus c. But because this is we're having lower limit and upper limit, so we are not going to put this constant of integration, that is c. So therefore, integrating this now, we're going to have sine what, sine x, because cos x, sorry, we have cos x. All right, cos x, I made mistake here, that is cos x dx. All right, so we have sine x. From there, we are going to put the what, we're going to put the limit minus 90 degrees and 90 degrees, okay. So this is going to be sine, putting the upper limit first, minus into bracket, putting the what, the lower limit, minus 90 degrees, okay. So now from here, so what is sine 90? Sine 90 is, if you press your calculator, it's going to give us 1 minus, then minus. So sine, this minus we have to come back here, or if you press your calculator, sine 90 will also give you what? Will also give you minus 1, or sine minus 90 degrees. So you're going to have 1 minus, we're going to have 1 plus 1. So from there we have what? We have 2. Okay, so the solution is 2. The solution is 2. So now looking at the option we have, you can see that we have the option C to be the solution, right? We have the third question. We have the integral pi over 12 to pi over 4, 2 cos 2x dx. So now we have this. Pause the video, do it yourself, then come back and check your result. Now solution. Now, firstly, we have pi over 12. You should know that pi is 180. So if you have pi over 12, it means 180 over 12. That will be what? That will be 15 degrees. We're going to have 15 degrees, right? So the lower part will be 15 degrees, okay? Changing from radian to what? To degrees. Then also, we're going to change this one. 180 divided by 4. 180 divided by 4. That will give us what? That will give, we're going to have 45. So we have 45 degrees, okay? We're going to have 45 degrees. This 2 that they say is a constant, we can take it outside, okay? Then you have just cos 2x dx. Now, what we need to do here is that we are going to, because of this 2 that is here, we have 2x. So we do replacement. Let u equals 2x. Plus 2x. Then find the derivative of du or u with respect to x. We're going to have du dx equals, and this is going to be 2. Now making the x, because we have x there, we want to transform everything from x towards to u. I get it now. We don't want to see any x variable here. So instead of x, we'll be saying u. So therefore, we want to make this ds the subject of formula, okay, equals du. And you want to make ds the subject, you're going to divide both sides by 2. So we have dx to be du all over 2. So therefore, anywhere you see dx over 2, okay, so you're going to replace it by du over 2. I mean dx, you're going to replace it by du over 2. So we're going to have 2 into bracket 15 degrees. We have 45 degrees. Now here going to be cos, 2x will turn to u. Then dx is going to be du over d over 2. Now from here, so you can see that from here we have 2 into bracket, integral 45 degree, 15 degree. So now this is like half. We can bring out half here. So if this half should come out, because it's also a constant, we have 2 over 2. We have cos u, then du. So now from here, you see that these 2, we cancel these 2 here. So we're going to have the integral of 15 degrees to 45 degrees cos what? Cos u du. So now, what is the integral of cos u? So the integral 15, 45 degrees cos u du. So now the integral of cos u is what? Is sine what? Sine u. Understood? So we're going to have what? Putting the limit 15 degrees, then 45 degrees. So you are going to put anywhere you see, but here, look at this place here. We have u here. So we are going to replace u. We recover that sine what? Sine u now is what? Is 2x. We're going to have 2x, then 15 to what? To 45 degrees. So therefore, you're going to have sine 2 times 45 first, because we're going to put the upper limit first before the lower limit, then minus sine 2 multiplied by 15. Are you following? Sine 2 times 45 minus sine 2 times 15. All right, so this is going to be sine 2 times 45 will be sine 90 degrees minus sine what? Sine 30 degrees. So now pressing your calculator, sine 90 degrees is going to give us 1 minus sine 30 is going to give us 1 over 2. Right, so 1 minus 1 over 2, we're going to have what? We're going to be minus, it is 1 over 2. But we're going to have this. So when you remove half from 1, so you're still going to have half. So that is what is happening here. So we are going to have the C, option C, to be what? To be the correct answer. Thank you. We have the fourth question. The integral of minus 1 to 1 of 2x plus 1 all to the power of 2 dx. So we have the options. You can pause the video, do it yourself, then come back and check your result. All right, so now we're going to, we have what? We have this minus 1 to 1, 2x plus 1 all to the power of 2 dx. So we are going to do, whenever you see anything inside the bracket like this, okay? So mostly you can let that thing inside the bracket be you, or just introduce any variable. We have 2x plus 1. So now you're going to differentiate this u with respect to x. You're going to have 2. When you differentiate 2x, you're going to have 2. When you differentiate 1, 1 is just a constant value, so that will be 0. So from here, we want to make dx the sorry formula. We're going to have 2 dx equals du. When you try to cross multiply, you can see dividing both sides by 2. This will cancel this. We have dx to be du all over 2. All right, so now you now go back to this integral. We have minus 1 to 1. Okay, so anywhere you see 2x plus 1 is going to be u this time around, multiplied by. But don't forget that we have square here, so you're going to put square. Okay, so now putting square here, we have dx. Dx is going to be du over what? Over 2. Are you following? So from there, you can see all the variables there now is the variable has changed to what? Has changed to variable u. So we have these two here. These two is found at the denominator, so we can bring it out because a constant, minus 1 to 1, then u square du. All right, so now what we need to do, if you remember, I told you that if you have integral of anything x to the power of n, this is going to be x n plus 1 over what? Over n plus 1 n plus c. All right, but here the c is just constant of integration, but here we are not going to put the constant of integration here, because we are, what we are giving is definite integral with upper and lower limits. We have 1 over 2. All right, so then we're going to have u2 plus 1, because we're having 2 already, then 2 plus 1. Okay, then you put minus 1 here and 1 here. Understood? Let me rewrite this. 1 over 2 u2 plus 1 over 2 plus 1. Okay, and we have the lower limit minus 1, the upper limit is 1. Now here we're going to have 1 over 2 into bracket u to the power of 3, okay, over 3 minus 1 and 1. But you need to recall that here we have u to be 2x plus 1. So anywhere we see u, you replace it. We have 1 over 2, okay, then into bracket we have 2x plus 1 all to the power of 3 all over 3, okay, then minus 1 and 1. We are going to put this minus 1 and minus 1 and 1 there. So now from there we're going to have, we first put 1, which is the upper limit. We have 1 over 2, okay, into bracket 2 times 1, we have 2 times 1, okay, plus 1. That is, anywhere you see x, you put what? You put 1 there, then over 3, then to the power of what? To the power of 3, okay, then minus. So you put minus 2 times minus 1, you're going to have minus 2, then plus 1 all to the power of 3 all over 3, okay. So only this numerator having the what? Having this 3, that is, which is the power. Then we have, okay, so we have 1 over 2 into brackets. Now here we have 2 plus 1, we have 3. So 3 to the power of 3 all over 3 minus here minus 2 plus 1. That is minus 1. Then we are going to have minus 1 raised to power 3. That will still give us minus 1. So we have minus 1 over 3. 1 over 2, okay, into bracket 3 raised to power 3 divided by this. We're going to have 27 divided by 3. We're going to have 9, okay, minus times minus, we're going to have plus. We have 1 all over 3, okay. So now let's add this together. So now to add this together, we're going to have 1 over 2 into bracket. Let me write it 9 1 over 3. So this is going to be 1 over 2. Write this 9 over 1. So we are going to have 3. 3 times 9, we have 27, right? Then plus 1 times 1, we have this. So we're going to have 27 plus 1, that will be 28 all over. 2 times 3, we have 6. Okay? So now from there, let's try to divide it. You can divide this by, let's say we divide this by 2, and I divide this also by 2. You see that this is going to give me 28 divided by 2 is going to give me 14 divided by 3. So how many 3 you're going to see in 14? If you want to write it in mixed number. So 3 in 14, that will be 4, because 3 in 14 is 4. Okay. 3 times 4 will give us 12, remainder 2. We have 2 over 3. So we have what? We have the solution to be 4 whole number 2 all over 3. And looking at the option here, you can see that we have what? We have the option D to be the solution. Okay. So thank you. We have the question number 5. The question says evaluate the integral from 1 to 2 of this function with respect to x, and we have these options here. So we just need to do this. Now kindly pause the video, do it yourself, then come back and check your result. Solution. So now firstly, we are going to, let me rewrite this. Now what I'm going to do here is that I'm going to reduce this function before I perform my integration. So firstly, we can see that this is quadratic function, x squared minus plus x minus 2. It's a quadratic function, but this quadratic function can be factorized. Okay, if we factorize this, so we're going to have it in this form. Okay, where you're going to have x here and put x here because of x squared. X times x will give us x squared. Now what will be here and what will be here? We're going to look for two possible numbers or factors of 2, so that when you multiply them together, you must have this minus 2. So if I say plus 2 minus 1, so you can say plus 2 minus 1 times minus 1 will give us minus 2, and plus 2 plus minus 1, we are going to have this one at the middle. So which is telling us that this x squared plus minus plus x minus 2 is factorized as x plus 2 then x minus 1. So if you put this, if you try to open the bracket again, so you're going to have this, right? So now from there, so we're going to replace it. We're going to have 1 2. So this one here, we're going to put this. We have x plus 2 then x minus 1 divided by x minus 1. Okay, so dx. So now we need to reduce. You can see we have something common here, x minus 1 here, x minus 1 here. So from there, we're going to have 1 2, then we're going to have x plus 2 only. Can you see that? Then dx. So now we're going to integrate this one. You first integrate x. If you integrate x, you're going to have, you know, x is having just 1 like this. Okay, it's having the power 1, but it's hidden. So to integrate x, you're going to have x 1 plus 1 all over 1 plus 1. Then to integrate 2, it's going to be 2x. Understood? It's going to be 2x because there's nothing there. We don't have a variable x here, but whenever you are integrating dx alone, okay, it's going to be x. So, and this 2 is just a constant. So we're going to have 2x. Are you getting it now? So from here, x into 1 plus 1 over 1 plus 1 plus 2x. Then we can simplify this to be x to the power of 2 over 2, then plus 2x. Now let's input the limit. We have 1 and we have 2 here. So firstly, we're going to put 2 here. This is going to be 2 to the power of 2, right, over 2, then plus 2 into 2. That's the first one, okay. Then minus, we're going to put the upper limit, I mean the lower limit, 1 squared over 2, okay, plus 2 into brackets 1 all the bracket. Are you getting it now? So we have this. So from there, you're going to have 2 raised to power 2 is going to give us, please, I would like you to write it down, okay, because I want to continue from here. So we're going to have 4 over 2, okay, plus 4 minus, this minus will affect this, we're going to have 1 over 2, and this minus will affect this one, is going to be minus what? Minus 2. So we're going to have what? 4 over 2, that is 2 plus 4 minus 1 over 2 minus 2. Now from here, so 2 plus 4, we have 6. 6 minus 2, okay, minus 1 over 2. 6 minus 2, we have 4 minus 1 all over 2. You can write 4 as over 1. Taking the LCM of 1 and 2, we have 2, right? So 1 into 2, 2 times 4, we have 8 minus 2 into, that is 1. 1 times 1, we have 1. So from there, we're going to have 8 minus 1 is going to be 7 all over what? 7 all over 2. So we have 7 all over 2. 7 over 2 to be the solution. Now looking at the option here, you can see that we have option D to be the solution. All right, so this is number 6. The question has to evaluate the integral of 0 to pi over 4 of sine x minus cos x dx, and we have these options here. So please kindly solve this. Pause the video and solve it, then come back and check your result. So now from here, the integral of 0 pi over 4 sine x minus cos x of the x. Now from here, what are we going to do here? So first of all, let's change the limit. It is in radian form, so let's change it to degree. That is pi over 4. Pi is same thing as 180, then divide by 4. So 180 divided by 4. So we're going to have what? We're going to have 45 degrees. So this is going to be 45 degrees. So therefore, pi over 4 will be 45 degrees. So we can have it to be 0 to 45 degrees now instead of pi over 4. Then sine x minus cos x. Okay. Then dx. Now from here, let's try to integrate each of these separately. So integrating sine x, we're going to have minus cos x. Okay. Then here, we are having minus minus. Integrating cos x, we're going to have sine what? Sine x. So we are having minus cos x minus sine x. All right. So now from there, let's put the limit there from 0 to what? To 45 degrees. 45 degrees. Okay, now so from there we continue. So to apply this, you can see that this negative sign is a constant. We can factorize it. We're going to have cos x plus sine x, okay, from 0, okay, from 0 to what? To 45 degrees. So now the negative is a constant value. We're going to have cos 45 degrees, all right, plus sine 45 degrees minus, so putting the 0, we have cos 0, okay, then plus sine 0. Okay, so now we have applied the both upper and lower limit. So from here we have minus. So what is cos 45? If you press your calculator, cos 45 is going to give you root 2 over 2 plus sine 45 degrees will give us also root 2 over 2, give us the same thing. A minus, using the minus to open the bracket, cos 0 here, I get it now, that is going to give us 1, but because of this minus, we would have minus 1. The minus will affect this, we're going to have minus, then sine 0, we have to give us what? They have to give us 0. So now from here, I try to rewrite this here. So now let's try to simplify this so that we have the same denominator. We can have it to be 2. Okay, root 2 plus root 2, that's going to give us 2 root 2, then minus 1. So now from here, you can see that these two, we have to affect these two. This, we cancel this. We're going to have root 2, okay? But don't forget the minus. We are omitting the minus. So we have a particular minus, okay? We have a particular minus here. So we shouldn't omit it. We have the particular minus here. So therefore, we're going to be having minus root 2. Then this minus will affect this minus. So we're going to have plus. So minus root 2 plus 1. So now trying to rewrite this, we're going to have 1 minus root 2. So 1 minus root 2 is the solution. Okay, so let's try to look at what we have in the options. Is there anything like 1 minus root 2? Yes, that is option what? Option A. So we have this to be the right solution. And so that's going to be the end of today's lesson. Okay, I'd like you to check or do research on more problems like this. Okay, so you can be able to pass your WAEC exam very well. So with this little or with this knowledge, I believe you'll be able to pass your integration questions or integration questions well in your exam. So thank you so much. Bye.